So yeah, several years ago, November, I was walking into the local grocery store, and in the front of the store they had a table filled with various decorations from Halloween that had not been sold. And right up there in front, I found Medusa, and she had a sticker that said $5. And I thought, wow, that's a bargain. So I thought this would be great to just like put on my bookshelf as a decoration. And part of the draw of this was back in the year 2000, I had come up with a series of circuits for the cell matrix that basically created multiple sets of wires that would grow and wiggle around and so on. And I had called those circuits Medusa circuitry. And so, having Medusa on my bookshelf at home just seemed appropriate. And $5, what a bargain, right? What I didn't realize until I picked her up, though, was that she's actually like... She's light sensitive, so if you get close to her, it changes the light input down by her mouth, and she talks. So she talks, and her lights in her eyes and her mouth glow green, and her snakes even wiggle around. So how fantastic is that? So yeah, that was Medusa. So there was this cool little button you could press, and when you had Medusa on a store shelf, if you didn't want to leave it motion sensitive, you could just use the button, and somebody could press it, and it would make her do her thing. And that went into a little connector on the bottom here, but one of the wires broke, and so we haven't been able to use that for a while. But that plug is just a simple 2-prong connector, and really all you have to do is short those 2 connectors out, and that makes her wake up. So the idea was, can we do something to trigger Medusa with a Wi-Fi connection instead of pressing a button? And it turns out it's pretty straightforward to do. So you can undo the screws in the back, and that lets you pull off the front cover. And you can see the inside, there's a battery pack and a main control board. So once inside, you can find the positive and negative battery connection, and they go into a connector to this board. And that external button comes into 2 points here, which goes down into the circuit board. Now I could pull the board off and see what's going on there, but with a simple ohm meter, it was easy to establish that one of these 2 pins on the connector is directly connected to the positive end of the battery pack. And so that's this connector over here on the right, which I marked with a little plus. And so that's a black wire coming out of this cable. And often when you have a push button activating something, the mechanism is to ground out that input. But on this particular board, it seems the way that you activate is to put 4.5 volts into this left connector. And so we just want to short that out, and that will go ahead and wake Medusa up. So the next goal is, how can we put 4.5 volts or some kind of positive voltage onto that red wire that's going into the back here. So I put a little hole here in the bottom of the base, and we can thread these wires through and access them internally, like so. And so those will sit, underneath the base, out of harm's way. And we're actually going to seal off the end of this wire, because this is 4.5 volts. We don't need that. To drive this wire with a voltage, we're going to use a little ESP01. It's an 8266, and that's a 3.3 volt device, but 3.3 volts on here seems to be enough to go ahead and trigger the mechanism. Alright, so how do you put something on the internet today? One of the easiest ways to do this is using something called an ESP device. There's two main lines, an ESP32 and an ESP8266. The 32s are larger. They look like this. They come with a whole Wi-Fi stack, an antenna on board usually, USB interface for programming, and then a whole bunch of pins for, you know, general connectivity. There's GPIO, there's I2C, and so on and so forth. This costs, you know, I don't know, $10 or something like that from Amazon. It works well in the Arduino ecosystem, so you can program it in C. You should be able to set it up to program in MicroPython also. And it's a pretty much slam dunk. It takes a few lines of code to put this thing online, and it will, you know, take on an IP address either statically, or it'll talk DHCP to your router and get an IP, and then you can make connections to it. So this is an ESP32. This is I believe also a 32, but it's got a built-in display. And if you look around Amazon, there's tons of these things available with displays and controllers and all kinds of things. And there's a lot of support online, free libraries, things like that. And it's pretty much self-contained, so super simple to use and get on the air. There's also smaller versions, so this one is, you know, a tiny little device, and, you know, fully self-contained, a lot of I/O capability. There's SPI, MASI, and MISO, and so on. Again, antenna printed on board. This one can be a little tricky to configure though, because there's no pins, and so you can pick up, you know, a programmer like this that, for example, I can take this and just pop it in here, and then get to those edge connections through, you know, something I can hook up to a breadboard pretty easily. For this project, I decided to use these ESP01s. They're about the simplest of this line of products I found. I bought a whole slew of them, and it's just 8 pins. So it's basically power. I don't know why it's silk screen backwards. It's basically power, ground, chip power down, 2 GPIOs, transmit and receive, and I don't know what the last one is. This also does not work well on a breadboard because the pins are too close together, but this same breakout board lets you plug it in here, and then you can get to those relevant signals through the appropriate pins here. And this, you know, you can power through a USB, you can program it, you can reset it through here, and so on. So it makes development really easy. And these things are very affordable. So just doing a check right now on Amazon, 3 of these for $9, so $3 a piece. 6-pack for $13. The best price I saw on here, 10-pack for $20. So about $2 a piece. And they're really just kind of universal workhorses. If you buy one, it's more expensive, obviously, but it's great to have a few of these around. Anytime you want to put something online, you can grab one of these, program it, and give it power, and you're good to go. So last question here is, what's the circuit we're going to use? Well, it's a pretty simple circuit. It's barely in need of a schematic. So we'll use a micro USB adapter, and we're just going to use this to farm out power and ground. So we have power, which is going to be 5 volts, and ground. We'll just, you know, have a common ground. We'll take this power, we'll put this into an AMS 1117, and that's a step down converter from 5 volts to 3.3 volts. So that connects to ground. We feed this in, we get our output. It's 3.3 volts, and this goes to the ESP01, and so that's got a connection to ground. we've got our 3.3 volts going into VCC. We've got to pull up 2 pins to make this thing work. After we've programmed it, we need to pull GPIO 0 high, and we need to pull the chip power down high also. And we can do those both through a 1K resistor. So that'll pull a few milliamps. And then this will, when it gets power, automatically boot up and start running our program. And then over here we have Medusa. And we take ground out of the battery pack and we connect that to a common ground. So it's got the same reference as, this board. And then we've got this wire coming out of the bottom that we need to put a voltage on, and we just take GPIO2 and connect it to that wire. And that's all we need. So pretty simple circuit. Sits on a proto board, and not a whole lot to it. The trickiest part with something like this is getting these 2 pins right. They've both got to be pulled up to get this thing to boot when it first gets power. But when you program it, you need GPIO 0 to be low, so we don't want to permanently tie it high. So we just pull it up through a 1K, and then same with chip power down. We want that pulled high. You do this, and it should work great. So we have our circuit board, and it will be USB powered over here on the left, and that will get dropped down to 3.3 volts through an 1117, and that powers the ESP board. And then this wire coming out here, this will be this is GPIO2. This will deliver 3.3 volts when you make a connection to port 80 on this device. So the hookup is pretty simple. We connect ground of this board to the common ground of the circuit board here, and then we take this red wire and we basically just connect it to this red wire here, and plug in a USB port in the back to get power, and it should put this device on the network. It'll connect to our local router and make a connection to the IP address, and it should wake up Medusa. So mechanically, the setup is pretty simple. I put a very small hole right down here that's lined up with where I want this micro USB port to exit. And so the circuit board will basically sit like that. And all I've got to do is a little rework with some files to shape that hole into the profile of the micro USB port. And then I'm going to hot glue everything, close it up, make sure it all still works, and then put her back together, and we should be good to go. So I closed her up after having cut a little USB slot in the back here for a micro USB to give power to the ESP unit inside, and now I can put her on the web. All right, so Medusa's back together. Let me show you the code that's driving the inside. It's a pretty simple script, so half of this code doesn't actually do anything because it's for debugging. But basically, button is GPIO2, and we put that into output mode and we initialize it to low. We set up a Wi-Fi manager. We try to configure it to 192.168.0.199. And when you call auto connect with a name like Medusa, it will do the following. It will try to connect to the router that it knows about, and if it succeeds, it will bring you down here out of the call. If it fails after a certain period of time, it will turn the ESP into an access port, and you can go to another device, and in this case look for a connection point called Medusa, connect to 192.168.4.1, and it will bring you to a page that lets you configure the Wi-Fi. So you can search for Wi-Fi networks, put in a station ID and a password, it will remember that, and the next time that you power the board up, it will try to connect to that. And assuming it does, it'll configure itself with this IP address, and then it'll start a server. And in this case, the server is going to listen on port 80. So up here, I created a server on port 80, and basically anytime anybody connects to port 80, this accept call will return with client. And when that happens, it basically sets GPIO2 high for half a second, and then sets it low, and then it sends a message back to the client saying hello, it disconnects from the client, and that's the end of it. So it's pretty straightforward, and I've got Medusa powered up. There. I should have her beside me for all lectures. So if I do a telnet, 192.168.0.199 to port 80, she comes up to life. And so anything that can make a network connection can be used to activate her. This is our music server, and I've got an option here you can click on. It does the same thing. So that's pretty much all there is to it. Hope that was useful, and if you've got questions or you want to see the code in more detail or something, send me a comment. Alright, thanks. Bye.